Dear grade 12 student, today we are going to talk about the third part of our new lesson, space geometry. So, the objective of this video is to know the mixed product and some properties about this product, and to know how we can calculate the volume of tetrahedron. Let's start by the mixed product. It's a mix between the scalar product and the cross product. For this, take these three vectors u, v, and w, where x, y, z is the coordinates of the vector u, and x prime, y prime, z prime are the coordinates of vector v, and x double prime, y double prime, z double prime the coordinates of vector w. The mixed product of the three vectors u, v, and w, written in order, denoted by u dot v cross w. We put this three vector in a matrix. The first row is the first vector u, the middle is the second vector, it's v, and the third row is the vector w. And as the cross vector, we put this matrix in the form of three determinants. Then, and we install the first column with the first row, it's x, we leave this determinant, we put minus, we install the second column with the first row, we put y, and we leave this determinant, and we install the first row with the last column, we put z, and we leave this determinant, and by calculation of this determinant we get the mixed product. It's a scalar quantity, it's not a vector like the cross factor. Let's go to an application. Consider the following vectors: u defined by 2i plus j minus 3k, and v equal I plus 4j, and w is equal to minus 5j plus k. The question is to determine the mixed product of u, v, and w in this order. So, u it's 2, 1, minus 3, v it's 1, 4, 0, and w it's 0, minus 5, 1. We need to calculate this mixed product, so put u dot v cross v, and put this three vector in the form of a matrix, u, v, and w, and by calculation we get that this mixed product equal 22. Now let's talk about some properties of mixed product. First property: if one of the three vectors u, v, and w is a zero vector, then the mixed product equal to 0. Second property: the mixed product is unchanged. It means that u dot v cross w equal v dot u cross w equal w dot u cross v. It means that if we change u by v or by w, the mixed product same. If any two of the three vectors u, v, and w are collinear, then the mixed product equal to 0. Since, by example, if v and w are collinear, then the cross vector of these two vectors equal to 0, then the mixed product equal to 0. Now, if the mixed product of the three vectors a, b, a, c, a, d equal to 0, then the 4 points a, b, c, and d are coplanar. It means that these 4 points belong to the same plane as shown in this figure. But if the mixed product of these three vectors not equal to 0, then a, b, c, and d are not coplanar. Therefore, a, b, c, and d form a tetrahedron called a, b, c, d as shown in this figure. Now let's talk about how we can calculate the volume of tetrahedron. If we have 4 points a, b, c, d such that the mixed product of the three vectors a, b, a, c, and a, d equal to 0, then a, b, c, d form a tetrahedron. And we know that the volume of this tetrahedron equal to 1 over 3 times the height times the area of the base. By example, if we have a height from B to the plane ACD, then the volume of this tetrahedron is equal to 1 over 3 times the distance from B to the plane ACD, it's BH, times the area of ACD. And if we have the height from A, we can calculate the volume by 1 over 3 times distance from A to the plane opposite to A, it's BCD, times the area of BCD. And finally, if we have the distance from C to the plane opposite to C, ABD, then the volume is equal to 1 over 3 times distance from C to the plane ABD times the area of ABD. Second rule, use the mixed product, it's equal to 1 over 6 times the absolute value of the mixed product of the three vectors AB, AC, AD. Let's go to an application. Consider the point A, B, C, and D. First question is to show that A, B, C, D form a tetrahedron. We need to find first the coordinates of the three vectors AB and AC and AD and calculate the mixed product of the three vectors, put them in the form of a matrix, we get 9 not equal to 0. Then A, B, C, D form a tetrahedron. Second part is to calculate the volume of this tetrahedron. Use the mixed product. Volume of A, B, C, D is equal to 1 over 6 times absolute values of the mixed product. In the first part, it's equal to 1 over 6 times 9 equal 1.5 unit cube, the unit of volume. Last question is to deduce the distance from B to the plane ACD. Let D be the distance from B to the plane ACD. We know that the volume of ABCD is also equal to 1 over 3 times the distance times ACD by cross multiplication. We get that the distance D is equal to 3 times the volume of ABCD over the area of ACD. But let's calculate the area of ACD. It's equal to half norm of the cross vector AC cross AD. Finding this vector by put AC and AD in this matrix, we get the vector AC cross AD as minus I minus 3j plus 2k. Calculate its norm. We get the norm of this vector equal to radical 14. Then the area of the triangle is half of radical 14. And finally, replace the volume and the area by their values. We get the distance from the point B to the plane ACD.